I want to say thank you to Catherine. I really appreciate the support that you've lent to this on a more daily basis than I. And I certainly appreciate the support that the research office and my colleague and my vice president, Sriram Rao, has given to this effort. But most of all, and of course, I want to thank all of you for being here. I very much appreciate that you're taking the time to work together with us in this really critical intersection of energy and the environment. But the most important thanks I need to give is to our visionary and to the person who has really been an international expert in this space, and that is Puru Jena. Puru has been a part of VCU for many, many years, but he's also been an incredible source of energy himself in terms of bringing people together, bringing some of the best ideas together. And really, this whole intersection of this multiple disciplines is a critical part of what we're really trying to achieve with this. It's going to take a significant amount of time. It's going to take a significant level of engagement with people of all ages, at all levels, and from so many different disciplines that we have not necessarily thought about. We typically have done so much of what we've done in our scientific silos and in our social science silos and so on and so forth. And that is where we've gotten made a lot of headway. But I think going forward into the future, if we want what I will call a real transformation, we're going to really have to bring together all of these folks that I'm talking about. Just yesterday, Puru and Catherine and I were together when we, I would like to say, broke the champagne bottle. We actually cut the ribbon on the new STEM building, the VCU STEM building. It's a really cool building. I have to say it exceeded so many of my expectations. But one of my expectations is that it will be a high-level LEED Platinum certified building. I don't know if we will achieve that. We won't know until the building is completely done, but I am really excited about the possibility that that might happen, and it certainly was my goal. What we've got to figure out how to do is to address something that actually came up right here in this room when I was together with the NSF director, the National Science Foundation director, Panchanathan. And this was maybe a month and a half ago, something like that, together with Senator Tim Kaine and Congressman Rob Whitman. So we were sitting here in this room together, and Panch is who our director, that's the name that he goes by. Panch basically said, you know, this is one of those institutions that really matters. And so I said, well, tell us more about that. He said, because you will be one of the few institutions in this country, if not the world, that has the greatest opportunity to help us capture the missing millions, the millions of people who have the tremendous potential to be a part, an important part of science and really creativity and understanding what we all need to understand. And we are missing millions. And that's one of the great things that when I was talking with Puru this morning, I was so grateful to hear about. And that is his target at K-12, engaging students and people at all levels. And we are missing millions and millions of people. Science cannot just be for a select few. We are in deep, deep trouble if that's the case. And that's not the case in the goals of this undertaking. And so we've got to have more innovation. We've got to have more different ways of thinking critically about how all of this works. And we've got to have more disciplines involved in thinking through how we deal with the realities of how we live as human beings, the needs that we have for energy, and how to sustain an environment that we know we need to deal with. We know it, right? We see signs of it all the time. The things that we have done as human beings, mostly, hopefully, well, including us, but human beings who have come before us, we just know it can't go on forever. And so how do we find ways through what we have been given, which is a tremendous amount of intellectual capacity, how do we figure out how to take these next phases of human life, the human experience, to a level that could be even better? So we have a lot of opportunity here. That's why Puru has done a great job of bringing so many great people together, not only so many of our colleagues from VCU, but also Costa's here from OSTP. Josh is here from the Secretary of Energy, which Puru has worked with for many, many years. One of our pioneers in the DOE space. Senator Hashmi will be here from the state, along with others from the state. Our national labs have experts who are here with us. And then some of our commercial partners as well, like Dominion Energy. And then of course we'll have many people from our own focus, our own places as well, the Wilder School and others that Catherine mentioned. I would say, as we think about one of Puru's really important goals, which is to engage so many of these millions who have not been on this pathway historically, we've got to find ways to think about how differently our students who are coming are going to expect their experiences to be than the ways that we have done them. So I would ask us to give thought to a lot of things in the scientific context, in the policy context, but also in the educational context. And one of those is that the Oxford and Cambridge ways of learning work for people who are at Oxford and Cambridge. I'm just telling you, I don't necessarily have a full opinion about this myself. I'm just being observant about the realities that the ways that we tend to communicate with each other and try to teach each other are not all of the ways in which most people seem to want to learn. So I'm not saying that we have to fight that. I am saying that we have to deal with it. And so as we deal with it, one of the things that I'm finding is that when we can give students in particular a context in which what we're asking them to learn starts to make sense to them and gives them a reason and motivation to want to learn that, it helps them enormously. It helps them enormously. This generation of young people want to make a huge difference in the world that they are a part of. They're more concerned than most generations have been about the people who will follow them. And we need to think about that. I really think there's an opportunity there. The other thing that I really hope for this institute as we kick it off is that we can do more to truly be as resistant to undue influences as possible and just focus on what we know has to be real. There are so many different influences. We have lots of reasons to now be more aware of those influences. We've got to be cautious about them. We got to be careful about how we navigate them, right? Because we want this to be a sustainable institute of sustainability. So with all of that, I'm very grateful to all of you for being here. Very excited about what this will do. And of course, I am absolutely issuing license to do what's right, and to stay away from the undue influences, from those areas where we really don't have a lot of evidence and where it's going to be dangerous for us to go, because winds will go this way and then they will go that way. And we need to stay where we know we can stay and make a positive difference that will be more geared toward what we know is the truth. So with that, thank you. Puru, I don't know how to thank you enough. You have so much on your plate. You have done so much. You have so many options. You could be anywhere in the world, and you often are everywhere in the world because you are in demand. But I do want to say to you, thank you for your leadership of this institute. It's something that we really needed, and you're the right person at the right time. I'm excited about what you're going to do, and I'm really grateful for the influence that you have leveraged to bring so many great people together. You know so many people in this world, and you brought them together to help us launch this in such a great way. Thank you.
Thank you so much, Dean Ingracia, President Rao, Professor Puru Jaina, and Ronnie Sisava for this lovely invitation to this most joyous occasion of the opening of ISEE. I'm very grateful to be here. It's an exciting time in energy. I'm going to talk a little bit about what we're doing in the federal government and looking forward to our continued partnership with universities and innovators around the country. I'm going to talk today about launching a decade of transformative climate action. I want to acknowledge my deputy director who runs our energy team at the White House Office of Science and Technology Policy, Dr. Sally Benson, and our energy policy assistant, Rachel Rioffi, who has worked on these topics with us. So I'm from OSTP, the White House Office of Science and Technology Policy, and we serve as the science advisors on all things technology and science to the president and to the executive office of the president in the White House. And in that office, Dr. Benson leads our energy team. And what our energy team does is bring science and technology expertise to our energy transition from OSTP. And so we lead assessment of how we can get all the way to net zero and what types of innovations are necessary in our energy system to get there. And we also understand the interactions between our energy system and our other systems, as well as our energy system and not just engineering and science, but social science as well. And I am thrilled that Dean Ingracia is here, and I'm thrilled that this center intersects between engineering, humanities, social science, business, because that's how we're going to get this transition done. And I'll talk more about that in a minute. So I'll go through this quickly so that we can get to the coffee break. That's probably what we're waiting for. As Professor Jaina has talked about, climate change is not an environmental problem. It's an everything problem. And it requires a solution across all disciplines. And the important thing to understand about climate change is every ton matters. Every 1/10 of a degree matters. Every year matters. And that climate change is not going to, we're not going to approach the 1.5 or 2 degree thresholds and declare victory or declare failure. Every bit of success that we have now improves the lives of everybody that we know now and everybody that comes in the future. The IPCC, as well as the US government National Climate Assessment, and all scientists and engineers around the world who have looked at this issue say, we need to get to net zero. And we need to get to net zero rapidly to avoid the most dangerous impacts of climate change. But a clean energy transition affects everything. It affects, of course, the environment, but it also affects equity and how the people who have contributed the least to climate change, as Professor Jaina has mentioned, often bear the brunt of some of the most extreme impacts. It affects the economy and the ways and the opportunities that we want to grow a new economy from the bottom up and the middle out. It affects security and our national defense and our supply chains. And it affects the way that we interact as a society on the future. Climate change sets the landscape on which the future unfolds. So we need to get to net zero and quick. But that is necessary, but not sufficient. We have an opportunity in this transition to do this with everyone and leave nobody behind. And that is very, very important to the president. So in this clean energy transition, we are going to get to net zero. We're going to create good paying jobs. We're going to increase equity and advance environmental justice. We're going to increase our national competitiveness, and we're going to enhance and increase energy security and reliability. So what have we done? On his first day in office, the president rejoined the Paris Agreement, and since has undertaken a historic set of actions that have advanced climate change action in the United States. So we have an agreement under the Paris Agreement to reduce our greenhouse gases emissions by 50 to 52% by the end of the decade. The president has committed 100% carbon emissions-free electricity by 2035 and net zero emissions no later than 2050. But one thing that may have gone under the radar if we're not working this day in, day out, is the president's executive order on federal sustainability in December of 2021. And what that does is lead by example and really set the opportunities that an administration has to demonstrate and deploy advanced technologies inside our federal agencies. So federal agencies are going to use 100% clean energy by 2030. Federal agencies are going to purchase 100% clean vehicles by 2027, or that. So I'm a vehicle person and kind of a electric transportation person. That by itself, I think, will catalyze an entirely new era of innovation in our electric transportation because it's not that far away. We're going to have net zero buildings, and we're going to build capacity and know-how that starts in the federal procurement and bubbles out into the private sector. President committed to environmental justice from day one and launched a Justice 40 initiative where 40% of the benefits, many of these programs are going to go to programs that have historically been left behind. We're also building a new energy economy with manufacturing jobs, advanced manufacturing jobs right here in the United States. Our solar manufacturing is 3 times today what it was before. We have unprecedented amount of investment in lithium-ion manufacturing in the United States. And we have a comprehensive assessment of our supply chain to figure out how we can do this clean energy economy better and grow opportunities for all. You may have heard of the bipartisan infrastructure law, and if you haven't, I'm going to tell you about it because it's very exciting to all of us, and I hope all of you. Bipartisan infrastructure law has more than $21 billion for clean energy demonstrations in hydrogen, in carbon capture, carbon dioxide removal, and advanced nuclear. It also accelerates leasing for clean fuels and clean energy on federal lands. Just a tremendous infusion of the federal energy R&D space happened under the bipartisan infrastructure law. And then there is the Inflation Reduction Act, which is the single biggest investment and opportunity in climate action by the United States, in history. More than $370 billion are available to catalyze a clean energy economy for everyone here in the country. So there are incentives for clean energy generation. There's incentives for clean fuels, clean hydrogen. There's incentives for energy efficiency and home improvements. There are electric vehicle incentives that are coming out that are growing a new electric vehicle economy here in the country. And there's all types of other ways that this is going to enhance and grow good paying jobs here in the country, including bonuses for communities in our legacy energy communities. And so this is a agenda that is designed to grow a clean energy economy for everyone. It also is an agenda, if we take it from the perspective of a center like ISEE, to find ways to contribute and advance energy innovation. So what starts here grows from around the world. So there was a long-term pathway that the United States put out in the fall of 2021 that says, here are some broad opportunities to get us all the way to net zero. I'll note that carbon capture and carbon dioxide removal provides 10 to 20% of the emissions reductions in the pathways that the administration had mapped out in the fall of 2021. But there are opportunities here for all the things that energy centers like ISEE and the research community and the startup community are excited and working on in buildings and transportation and in industry. So like any long-range plan, the university administrators like to make long-range plans. There's lots of bullet points, but let me just focus on 2. Net zero electricity by 2035 and electrify light-duty transportation, heating, and a big portion of industry. Those 2 by itself are going to require innovations and action from folks in this room and from around the country. So for these pathways, there's no right answer. The only right answer is on the right side of the equation, and that is equals 0. Right? Everything else on the left side is up to the innovators in this room and around the country. And so as long as we get to that, those opportunities that are consistent with the values and growing the good-paying jobs in the United States, there are different pathways that we can take to get there. We know the broad contours. But in the electricity sector, we know we need to deploy lots of renewables. We know we need lots of energy storage. We know we need clean, firm power. And we know we need to understand how these are going to interact with each other as we're growing the electric sector. And I'll talk more about that in a bit. So today, as this is familiar to many in this room, but when we go out and talk about this, we want to hammer home the importance of systems thinking and systems analysis in the energy transition. Today's energy resources are providing energy services. We want cold drinks, we want hot showers. Those are converted depending on how we're generating those and delivered. And we're ultimately getting these services in our homes and businesses in our industry. But all of these components, resources, conversion, transport, and use are interacting in near real time and all have to work all the time. And real-time delivery is built across a century-old legacy of how the system works. Now we're layering on top of this new and digital technology. So the interaction of the cyber-physical is critical on the way that we transition this new energy economy, because we need a deeper understanding of energy systems integration. We need a deeper understanding of how we do optimization and coordination for when we have new resources that are variable. We have new resources that have different supply chains. We have new resources that are going to different parts of the country, and we have new demand as we grow the economy and as people are both here and around the world use more energy. So real-time delivery is going to get more complex. That doesn't mean that it's, and so again, if it gets more complex, as long as we can still deliver cold drinks and hot showers, that's what that's what society deserves. So it's up to the innovators in this room to figure out how to manage this complexity. Electricity is likely to become our primary source of energy for more than half of our end uses. As we electrify our vehicles and our heating and much of our industry, and as we think about generating new ways to do hydrogen production, our electricity system is the backbone on which the future clean energy transition unfolds. We're going to need end-use devices that respond in real time to supply side signals and interact with the grid. We're going to need two-way power flows and distributed sensors. And we're going to need the computational tools to model and understand how this all works. Now, as you all know, a model is only as good as what you put into it. And so as you're building these models, I'm encouraging you to work with the social scientists, work with the business community, and work with the rest of the community that is centered here in ISEE to understand, well, the model said on paper that everybody wants this. Well, is that true? Did it happen? Why didn't it happen, right? And building that expertise into our assessments, into the models from the beginning can ensure we have more success at the end. But of course, there's lots of engineering and science opportunities, new science, new equations, new ways of doing things in control and optimization, in collecting data and doing real-time analytics. I think it's important that we've been able to make a giant leap between, say, 2000 and today in the way that we manage and understand our energy system. But we still have a lot more real-time assessment and real-time intelligence to go to deal with this giant moving project of decarbonization. And so there's three critical and interconnected challenges around this first part of this that I'm talking about. It's advancing electrification while leaving nobody behind, while also decarbonizing the power grid, while also dealing with what we heard about from Professor Jaina, that our energy system has historically been a driver of climate change, but our energy system and our infrastructure are also on the receiving end of the impacts of climate change. So as we design a new energy economy, it needs to be designed for the climate and weather of the future, not the climate and the weather of the past. And as we make sure that people are safe from extreme weather and safe from climate damages while we're redesigning this infrastructure, it can't look like it did before. So I have been mentioning electrification. I just wanted to show a couple different pieces of why that's important. And so what this is showing is that the type of energy that is used in many of our devices varies. And as we might expect, nearly 90% of our energy in our transportation system is from petroleum products. And so when we shift from a petroleum-dominated transportation system to an electric vehicle, because petroleum plays a very, very small part in our electricity sector, less than 1% in the continental United States, we're basically shifting completely away from petroleum products into the diverse fuels of the electricity sector when we electrify our vehicles. So there's a large opportunity to increase energy reliability, energy systems decarbonization, and reduce pollution by getting to electric vehicles. Similarly with space heating, about half of the space heating in the country is from natural gas. And as that can be electrified with very efficient heat pumps, which by the way, there are tax credits and incentives under the Inflation Reduction Act, that's another very near-term opportunity to shift from a carbon emitting source to one that's potentially less carbon emitting. And again, as we move down into industrial processes and other buildings and agriculture, electrification provides a foothold for the energy transition, and we should be finding ways to make it work, make it affordable, make it accessible, and make it rapid. So we are going to have to accelerate electrification at 4 times the historic pace. And if for those of you who have been in the utility sector or been thinking about or been working in the electricity sector has basically been on a kind of flat load growth over the last decade or so. And we're going to have to return to the growth mindset, growth and abundance mindset of how do we ensure that we have electricity and electrification for everyone while make sure that it's reliable, affordable, and clean. And that's going to require how we design new devices, both in the generating side, transmission, distribution, and at the end use. It's going to require all that optimization that I talked about and making sure it all works together. But then the last part that I promise I didn't put here just because it was the center here at ISEE. ISEE has a social science and humanities component. This is very much at the heart of what we do at OSTP, is bring together the social sciences, the finance, and the engineering and sciences, because that's how it's going to work. So this last part on the bottom is social and institutional innovation and how these types of technologies, new technologies that folks may not be familiar with, new technologies that folks may find risk in, how do we make sure that the risk is reduced, that the benefits of new technologies are harnessed for everyone, that the impacts of new technologies are minimized and do not disproportionately fall on communities that have historically shouldered a lot of risk. This is foundational to the energy transition. So one example here is why electrification can help immediately is that a lot of the urban air pollution in cities comes from the transportation, tailpipe exhaust from the transportation sector. And as we can move that tailpipe exhaust to the electricity sector, where we have increasingly cleaner generation, we can immediately remove a lot of the ground air pollution in communities that are overburdened and dramatically improve health outcomes. So this is more than whether an electric car is fun to drive. It is. And whether an electric car is cheaper to drive. It is, by about 70% in most cases. This is about our neighbors and ourselves breathing cleaner air. Now you thought that by itself is a reason to advance in the energy transition. Here's where communities like this need to step up and step in. If we think about the types of loads that you have in your home, maybe you have an electric water heater, maybe you have an air conditioner, maybe an electric clothes dryer, dishwasher, right? I've put here the approximate, and I know Professor Jaina is probably going to tell me and I've gotten some of the numbers wrong, but I'm close, right? So imagine there's error bars here. I put here the approximate loads of those devices that we count on, rely on all the time when they're running. And so if I add 2 electric cars to a household load, I can nearly double the peak load. And we need to make sure that every part of the energy system is ready for that. In most places it is, but we have to make sure that as more and more adoption of these electric technologies that are benefiting consumers and the environment happens, that these technologies are integrated smartly and the energy system reliability is increased. As neighborhoods electrify with new devices and new vehicles, we will need to pay attention to our local distribution system. This is the first line of defense and infrastructure that we should be paying attention to in electrification. I worked in electrification for a long time, and a very good question that people ask is, do we have enough electricity to power all these new vehicles? The answer is absolutely. And a kind of a good rule of thumb that I always use, if you flip the entire US light duty vehicle fleet over to electric tomorrow, you'd need about another 25% total kilowatt hours that we generate. So we're not going to flip it over tomorrow, but we're going to do it very rapidly. But that gives you a sense of scale of what that would mean for the grid. Now, we need to advance our light duty electrification rapidly and advance our other appliances electrification rapidly. And so what that means is the power plants are important, but the first piece is the kind of invisible infrastructure around us: distribution lines, distribution transformers, substations, transmission. So as neighborhoods increase, these are opportunities for our engineers and scientists to think about optimizing and deploying new technology. As our regions electrify, now we need to make sure that we have regional transmission capabilities. We need to make sure that we have more smart generation so that we can meet the needs of a growing electric economy over the coming decades. So what are the actions to get to our Paris Agreement targets? Well, we're going to deploy, as Jigar Shah of the Loan Program Office says all the time, and we're doing that. Solar, wind, batteries, efficiency, transmission, and charging stations. The president has made a commitment to install 500,000 charging stations by 2030, and we're well on our way to making that happen. As I mentioned, the bipartisan infrastructure law provides large-scale demonstration project resources to really prove and grow the types of learning that happens when you build something, when you put steel in the ground and you make that happen. And also, we're not taking our eye off the ball. We can do all these things while also invest in game-changing innovation. And so this is not, there's an old kind of battle between deployment versus innovation. We will need both and a lot of both. So we need new systems thinking with urgency around innovation and discovery-based research and applied research. So along with deployment, we have to ramp up our innovation cycle. And that's the last part of the talk. I'm going to talk about that. Our long-range plan that I mentioned before creates a blueprint for the bounds of the transition. And now it's up to the innovators and the researchers and the firms to figure out how do we get from where we are down to zero. So our office, the energy team in the White House Office of Science and Technology Policy, led an interagency effort on U.S. innovation to meet 2050 climate goals. We released this report last year, and we worked with 17 agencies across the government, including very much our good friends and partners at the Department of Energy. And what we did was look at what are the technology areas that will be absolutely essential to increase the likelihood we get to zero faster, cheaper, and more equitably. And there's a lot, right? We identified 37 to start with. And so these are across all the sectors of the economy: in transportation, in electricity, in industrial, in buildings, in agriculture, and in carbon removal, as well as a whole bunch of things that cut across these sectors. And so this report is published on the web. I'm happy to talk more about it, but I encourage you to go through that because that is the type of opportunities that are wide open. Imagine being, for the students that are in the room, you are at the beginning of this new era of science, engineering, and research in social science, that the table is wide open to do really amazing things. In order to identify these and start to advance some of these game-changing opportunities, we didn't just look at cost. We didn't just look at technology availability or technology feasibility. Now, don't worry, mechanical engineers, we still obeyed the laws of thermo, right? So that we made sure that it's technically feasible. But beyond that, we have to go to understanding, can it get us to zero? Is it necessary to get us to zero? What are the impacts for jobs and for disadvantaged communities and for environmental justice and for global energy access? What are the opportunities and for broader impacts across the economy? What are opportunities to increase security and reliability? So this is what we call a multi-objective framework, right? As the researchers will attest to, sometimes you optimize for one variable, sometimes you optimize for many variables. All these variables need to be at 100, right? So there's no discounting of any of these important topics. They all have to be maximized. So I won't go into this, but this is evidence of a multi-objective framework across different attributes and across different technologies. And this is the process that this group went through to think through, how do we get to net zero across these 37 game-changing technologies? And so we identified which ones would have transformational impact, right? This is impact across lots of sectors. We identified the ones that have broad impact, and then targeted. And so we worked on targeted. We wanted to say something that didn't mean small, right? Because targeted does not mean small. It just means it focuses on one sector of the economy rather than every sector of the economy. We are going to need, near zero CO2 aluminum and steel and cement. And we're going to need electric and hybrid aircraft. And we're going to need no CO2 shipping. Again, these are innovation opportunities for entrepreneurship, and discovery that are wide open. So I'm going to talk about, in this last bit of the talk, the first 5 of these. So you start with 37, and we said maybe we just, after we identified the 37, our next step was let's start with 5 and work with our agency teams to say, what do we need to do for these 5? And then we'll repeat the process. And so now we're diving into a couple of these to start with. So the first one, as you might expect, net zero power grid and electrification. So this is really about the end uses. And this is about making sure that we can enable a distribution system that manages all of these new loads that I've been talking about and increases energy system reliability and resilience. This is a kind of a multi-tiered effort to connect generation, transmission, distribution, and end uses all in one place, so that we're doing this research across these different spaces. Because sometimes you push on one thing and something else pops out in another direction. We need to have all of these connected from the beginning so that we're advancing electrification for everyone. So the next one, and I don't want maybe the folks in this room don't get bored with air conditioning. I love heating, ventilation, and air conditioning. Very important, right? It's both super interesting from an engineering perspective, but it's also very important from a public health perspective. Because as climate impacts advance, ensuring people have adequate cooling is a justice issue. Ensuring people have access to heating in the depths of winter is a justice issue. And so we need to make sure that heating, ventilation, and air conditioning is affordable, accessible, widely distributed, and uses refrigerants with very, very low global warming potential. And so there's all kinds of innovations that can happen on designing new refrigerants, designing new systems, deploying new systems, the social innovation of how systems are advanced. As I mentioned, there's Inflation Reduction Act tax credits. But this is, how do we ensure that as we're electrifying our heating system and adding air conditioning, that we're doing it in a way that advances all of these objectives? So the next one, this one's challenging, right? Net zero aviation is an innovation opportunity. Let's look at it from the positive of what engineering challenges does the innovation community have before it for net zero aviation? Lots. We want to enable people to have mobility, and it needs to be with zero carbon or net zero carbon. And so there's going to be new innovations in bio-based net zero jet fuels. There'll be new innovations in electrochemical net zero jet fuels. There'll be new innovations in electric and in hydrogen. And there'll be new aircraft designs and new opportunities for mechanical and aerospace engineering. There's also new opportunities for assessment of impacts of all these innovations as air travel grows both here and around the world. Is how does this affect communities and how those impacts can be minimized? So net zero aviation is a important and wide open innovation opportunity for the energy innovation community that I would encourage you all to look at and partner with the federal government and companies to help solve. So this one is a big one, right? So remember, we started with 5. I know some of the professors in the room sometimes will give you kind of like a question with 5 parts, right? And everybody gets upset with that. That's what this one kind of is. So industrial products and fuels for a net zero circular economy. It's a big portion of what we're trying to do in the industrial sector. And so this is about solving what some people would have called the hard to abate sectors or the hard to decarbonize sectors. Why is it hard? It's hard because we haven't really tried, right? And so now it's time to try. And it's time for success, because we are going to find new ways to make materials and recycle those materials and have circularity in those materials. We're going to find new ways to alleviate vulnerabilities in the supply chain. We're going to find new ways to do advanced manufacturing with good paying jobs, both here and around the world. And we need to have these get to net zero. And the important piece here is it's wide open. And there's super great opportunities here for us to make a large dent across all the sectors that I was talking about before, in people's lives, in communities, in jobs, and in air pollution, to help an industrial economy grow, provide for the needs that we need both here and around the world, grow the types of jobs that are important, but also do this with less waste and growing, kind of working with nature instead of against it. And designing new materials and thinking about new ways to doing things. And so industrial products and fuels for a net zero circular economy is this big thrust that we're trying to advance as part of this game changer framework. And so the last one you may be surprised about, So the last one I know that Professor Jaina as a physicist is excited about. I am excited. I'm a civil engineer. Even I am excited about fusion. And let me tell you why. It is just from a purely science perspective, it's wondrous, right? It's just the idea that we can capture and create a star inside of a bottle here on Earth is just a marvel of science and progress. And so fusion energy at scale is one of our game changers, because remember, we're thinking about the long term. We're thinking about what is the investments that need to be put in place now so that we have innovation in the 2030s, the 2040s, and beyond, in the 2080s. And so we need to be always advancing science and engineering progress to ensure our net zero goals are met, but also the world doesn't stop in 2050. We have to ensure the types of technologies that are power our world for a long time to come. And so fusion has been going through a renaissance and has had lots of private investment and capital. There's been major breakthroughs. You may have heard from the one at the Lawrence Livermore Laboratory last year, but there were a series of breakthroughs before. Some of them have been enabled by the Department of Energy's ARPA-E program. And so investments in early stage and very early stage technologies have yielded really positive results. And so we don't have a power plant yet, but there are opportunities to learn and grow along the way so that we can get there. And the president launched a bold decadal vision for commercial fusion energy last year at a summit. It was the White House Summit on Fusion Energy hosted by our office and the Department of Energy. And that the first White House Summit on Fusion Energy is something that we brought together people from around the country to figure out what's necessary to advance this really game-changing energy source with near limitless fuel. Now, we also, while I'm talking about our summits, because these summits will tell you kind of what we're trying to focus on in advance. We had a summit on electrification. So we had the first White House Summit on electrification. We had the first White House Summit on climate and communities, and thinking about how communities like Richmond can work together with universities to advance not just climate research, but net zero deployment. So how can VCU and other universities help their communities learn what it looks like to be a net zero community? And then we had a White House roundtable on circular economy. So one of our functions at OSTP is to bring these communities together, help share and lay out a vision and get to where we need to go. And so on fusion energy, the President, the Department of Energy, and the White House are excited about the opportunities that we're advancing in fusion. So this is where we're going to need your all's help. Typically, we heard from Professor Whittingham the way that lithium-ion batteries were discovered, and that there was IP generated, there was prototypes, it went in different directions, amazing discoveries that we rely on every day right now. A lot of times, and we looked at this and others have looked at this as well, is in the history of technology development and commercialization, things take a long time. That battery was kind of first discovered decades ago. And now we're seeing batteries that are viable and cheap enough to be in cars and on the grid. And so the basic science, the discovery-based science that many of you all are doing every day that is critical to the future of humanity is absolutely essential. As that basic science grows the pool of knowledge, there's maybe a proof of concept emerges, and then technology development, and then there's regulatory issues and market frameworks. All of these things take a long time because they're typically done in series. And we do not have 70 years to do the next generation of energy innovations that I'm calling for here. We have much shorter time. So again, how do we make something go faster when it's in series? We're going to put something in parallel, and we're going to do parallel processing. So just like a computer will take a big task and divide it up amongst several processors and do it different parts of the task so that they can come back together, we're going to need to do basic research, innovation, engineering, proof of concept, policy development, regulatory environment, all kind of at the same time, so that one piece is feeding off another piece. And so with maybe the regulatory environment says, what would be safer is if you did something like this, and then engineering and science can go back and fix it that way. It does not have to be a linear process of innovation. We can have this be more of a parallel process so that we can get to the market commercialization of these exciting technologies and integrations much, much faster. So 10 years, maybe on the short end, we'll give you 15. That's fine. We can, it's from discovery to scale up. But what we need to do is we know that a linear process is going to take 70 years is not viable for our current climate scale. So Dr. Prabhakar, who's the head of the Office of Science and Technology Policy and a cabinet secretary, she likes to talk about doing things that the climate notices and doing things at the speed and scale where the climate notices. And her vision has infused all the things that we're trying to do here is that speed with care, speed with inclusion, speed with equity, and speed with scale is how we're going to need to approach this and tackle the climate crisis. And so there's roles and responsibilities for the energy innovation community, the social science community, law, business, finance, trades, construction. There are opportunities in the clean energy economy for everyone. And we have a vision that we hope that we can partner with the rest of this community on. So how do we align our energy transition goals, right? And so this is all the things that need to get done. We need to get to zero, right? We need to get to net zero, and we need to do that no later than 2050. We have to do that by building broad coalitions and creating good paying jobs. We have to advance environmental justice. The president signed an environmental justice executive order 2 weeks ago. We have to clean up legacy pollution. There's opportunities here for new ways in designing pollution. As this world advances and energy becomes more and more intertwined in our daily lives, we need to make sure that we have energy security and that we're increasing our economic competitiveness and maintaining our relationships with our partners and allies. So we've just now added to your list of things that need to get done, all within, let's call it 25 years. I am very confident of the innovators in this room and around the country that can work with the research community, with our wonderful national lab system, with the university system and community college, and with our K-12 education system to all row in the same direction of getting to a clean energy economy that is grown for everyone. And so I am excited to be here. Congratulations on the opening of this wonderful center. I and the rest of the White House are looking forward to interacting with all of you on this journey. And we'll see you back next year here, hopefully with some new innovations. Thank you so much for having me. Appreciate it. I think there's some questions, and Professor Jenny, do you want me just to take the questions? I'm happy to do whatever you'd like me to do.
Please go ahead. Seem capable of fielding your own questions.
Okay, well, that's dangerous. We'll see what happens.
And microphone.
I'll just stay up. I'll stay up. Yeah, that's fine. Yes.
Yeah, one of the things, thank you for the great insights. And again, I'm a great admirer for things that are doing. And most of them are quiet revolution, like introducing heat pumps in the houses, that can, I'm just giving an example, electric vehicles. But my question is, one of the things, electrification of cars is batteries. Do we have supply of raw materials like cobalt, nickel to convert whatever the target of 2030 is? Because China has cornered all the cobalt in Congo.
So the question,
how is being handled?
The question,
purpose the raw materials need for batteries.
the question is, what does the supply chain for raw materials look like for electrification of vehicles, and how do we meet those challenges in the very near and mid and long term? So the president and the White House initiated a process of understanding the supply chain for critical and raw materials. Department of Energy had a big lead role in that and has produced a series of reports and actions that the administration is taking on ensuring that we have the raw materials necessary for the clean energy transition. On electric vehicle batteries especially, there are new chemistries that have been developed that don't rely on these some of these more harder to get minerals. There's also the opportunities for a more circular economy. So I believe that we have in the near term a plan in place to ensure that we have access to the materials that are necessary, and that innovation that we see in new batteries like lithium iron phosphate, and we've heard just of this past month we heard innovations in sodium ion batteries. We should not assume that the batteries of 2038 or 2035 look like the batteries of 2023. And so I am excited about the possibility of broad innovation when the world starts focusing on electrification of vehicles, on what battery chemistries, battery materials, and battery costs start to look like.
Other questions, Crosby?
So this was very informative and useful. Thank you for a very, very elaborate talk. So my question is, as we move along with our net zero plans and all of this, what's the strategy for engaging the industry? Because they are the key people who are going to be deployed. So from the both policy side and from the implemented strategy side, just would like to know.
The part of the administration's engagement from the beginning of this administration has been with our clean energy industry innovators. And so you're absolutely right that the electric vehicle manufacturers, the battery manufacturers, the steel producers, the cement factories, all of these folks who are day in, day out delivering the types of products that we all rely on are key partners in advancing this clean energy transition. But I'll also add a partnership with labor. And so making sure that that communities around the country have access and opportunities for good paying jobs is key. So this is going to be a partnership with industry. It's going to be a partnership with labor. It's going to be a partnership with research. It's going to be a partnership with education. And so we know, as much as I would love to write papers and let them sit there, that's what I used to do, and I still like to do that, by the way. I'm happy to write some paper. I want to make sure that the stuff in those papers gets to a device, gets to the things that we want. And so a partnership with the folks that are doing things on the ground has been our operating tempo from the beginning.
Thank you for the talk. With regards to nuclear fusion, having a pilot plant on the grid in 10 years is certainly an admirable goal. What's your budget plan for that?
So if you look at the president's budget request for this coming year, there is a large increase in the budget for fusion that has milestone program requirements and opportunities and other materials and research areas. Obviously, to advance any type of new technology is going to require resources, and we are taking the appropriate steps to make sure that we're growing these fields in a way that is commensurate with the challenge. Now, it's important that in fusion, especially, the money from the public sector catalyzes all kinds of investment from the private sector. So our public sector budget has grown. And what that has done is increased and poured new attention into fusion from the private sector. So between the public sector and the private sector, I'm confident that there will be resources to make sure that we're advancing towards the president's goal.
Hi there, I'm Damian Pitt. I'm Associate Director of this Institute and also Professor of Urban Planning here at VCU. So first of all, thank you for the great presentation and the comprehensive strategy that this administration is taking towards the clean energy transition. But from the perspective of my field, there are a couple of big concerns, or like what I would consider omissions in the strategy related to transportation. First of all, I'm not seeing the commitment to reducing vehicle energy demand in the first place, right? So as we, and as it relates to the transition to electric vehicles, we also should be reducing vehicle miles traveled, reducing automobile dependency through better mass transit, intercity rail, et cetera, which we've not made much progress on in this country in many decades. And the second piece is with the EVs themselves. Like, we have this very complex system for determining which types of vehicles gets tax credits and which type of manufacturers get tax credits. And the end result of that is that it's almost entirely large, expensive, many of which would be considered like luxury vehicles that are being incentivized now. The one EV that's made in America that is small and affordable is the Chevy Bolt, and we learned yesterday that that's not going to be made anymore. So how can we better use, focusing on that second part of the question there, that second concern, how can we, what are we going to do to incentivize smaller, more affordable EVs that are also safer for pedestrians? We have a increasing number of pedestrian fatalities in this country, and the transition to large, heavy EVs is a major concern there as well.
Thank you so much for that super important point and question. 100% absolutely, we need safe streets for everyone. We need communities that kids can feel safe playing outside in the streets, and opportunities that increase roadway safety, not just for drivers, although that's super important, but for cyclists, pedestrians, and everyone else. In the bipartisan infrastructure law, there was the largest investment in passenger rail and public transit since the creation of Amtrak. So the president's actions have demonstrated the commitment to public transit and to passenger rail. We need to make sure that our strategy for transportation is electrification plus. So there's not going to be one thing that's going to solve this challenge. It's a lot of the different elements that you listed to make sure that we get net zero, safe, equitable mobility and access for everyone.
What about smaller EVs?
For smaller EVs, there are opportunities for, so let me put it in the personal. where my family lives in Pittsburgh, there are hills everywhere. And so I would not bike to work because it was uphill both ways. But I got an e-bike, and it basically changed the way that I use these short trips. Most of the trips, as you know, that people make in the country and in many parts of the country are fewer than a couple miles. And so there are opportunities for shifting from car to public transit, shifting from car to e-bike, and finding ways to make our vehicles safer for both pedestrians and other drivers. So absolutely agree with you that this is a multi-pronged strategy that's necessary.